Hi guys, this will be statistics 2 week 10 graded assignment. So first of all we are given uh, normal values for normals of different values, right? So the probability of them, here comes the question that the average marks scored by a student of a school in their board exam is to be reported 400 with a standard deviation of 5. You suspect that the average may be lower than the possibly like 390, and then you decide to sample the students to find their marks, right? Let me change another music here. Yep. So first of all we need to find the sample size with the significance level of 0.05 and the power of 0.95. So let's begin. I'm sorry. So let me make this whatever. So first of all, let us take the random variable. Yeah, white is good. Random variable, let us say x. So this random variable is what represents the total marks obtained by the students in their respective board exams, and this random variable, board exams marks, right? This random variable has two individualities of mean and standard deviation. Okay, and here in the question this is given as 400 and standard deviation is given as 5. So let us suppose there's a hypothesis and zero space, you can say null or alternative hypothesis, where h is where mu is equal to 400 and h dash is where mu is less than 400, let's say. I hope you get this. So now we will conduct a test here. Test for mean of x, random variable, right? So mean of the random variable here, let us suppose, is less than some value c. The mean of random variable is less than c. So, and this is at the significance level of 0.05 as given in the question here. You can verify it. I have opened another file, so let me see. Let's recheck. Yeah, it is for 0.05. So here we can definitely say that, let us denote this with significance level, which you generally denote as alpha. So let us say that alpha is probability of h naught, basically the complement of h complement upon, this is the conditional probability here, so we will write it h complement upon h. Basically what I am trying to say here is that we are finding the probability of this being rejected. Let me use another pen here. Probability alpha is equal to probability h being rejected, right? And condition to the probability that h is true. Okay, I hope you get my point here. So this is basically the alpha what I am trying to consider. So we will just find the probability for this. Now you already know, applying central limit theorem, or its alternative you can say, that mu minus this given mu upon standard deviation divided by root n. This gives us the normal 0, 1. I hope you agree with me to this part, right? So I'll be removing this. Right. So basically, yeah, red is fine. I can use yellow here. So the probability now here, x dash is the mean which is supposed to vary. So this minus the given mean, which is 400, upon 5, which is the standard deviation, divided by root n, and here we need to find the n, right? This will be less than c, this factor, minus 400 divided by 5 by root n. Basically we know the probability for this, right? So probability of this is equal to alpha. Isn't that true? Let me rewrite it here. Probability of x dash less than c will be equal to alpha. So I just rewrote this all. Alpha is basically 0.05, and which is basically this part here, right? So all left is to equate. So I'll remove this all, delete. So let me remove this one also, right? So what we got there was that f of z of c minus 400, you can go back to the video to check this values. I'm sure it will be same, is equal to the alpha, which is 0.05, and taking the inverse of that, or you can see that in the given diagram, if there is a value 0.05, let me just recheck. Wait a minute. So yeah, 0.05, f of z is 0.05. Yeah, no, it's 0.005. 05 will be yeah, here it is, this portion, right? So basically we can say for sure that we can write this thing as f of alpha is equal to fz of minus 1.64, or alternatively we can write it like c minus 400 upon 5 root n will be equal to minus 1.64. I hope you agree with me to this point. It is basically the simple old syllabus topic and the way to solve, right? So now all is left is calculation here to get the value of c. So from this we can say that c will be equal to minus 1.64 into 5 by root n plus 400. Now we only found our c. Basically this is the value which is for which the significant value will be which we will got. Basically, let me just rephrase my wording. So we just found the probability of an expected mean to be less than some value, and that some value is this thing. So basically we can say that probability of mean being less than C is equal to 0.05. Let me just say it again. Probability of mean being less than this value, which is C, is 0.05. I hope you got my point here. You can just listen it one more time, but it is what it is. The probability of getting the value less than C is equal to 0.05, and we just found the value of C. So what all left is to put the beta. So alternatively, we can say that the beta is probability of H being accepted conditional to H is true, right? So let us suppose we got a beta here. So what do you think beta is? Beta is the power level, and power is basically 1 minus that of significant level, which would be 0.05. So we can say here, let me just make this all smaller to get a bigger space, right? So this was pretty simple up till now. So we can say probability, before we found probability of X less than C, right? Now we can say the probability of expected mean to be greater than or equal to C is equal to 0.95, right? This. Now here this is kind of confusing, but we can say in the question it is given that the average may be lower than possibly 390. So we will assume C to be 390. So we can say that X minus 390 upon 5 root n will be normal 0 to 1, right? We will use the same here, and from that we can say pretty strong wording is used here, that basically it's same thing if we are pretty strong in central limit theorems, right? Is less than C minus 390. I hope you got my point. Before we were saying that alpha is the probability of X being this expected mean to be less than 400, and now we are finding the probability to be expected mean greater than 390. That's all. So 390 upon 5 root n. Now we already know this is equal to 0.095, so we can say f of z of C minus 390 upon 5 root n is equal to f of z of basically it's equal to 0.95, and we need to find the value of f of z of this. So f of z of 0.95 here, yeah, it is 1.64, basically the modulus of the previous one. So we can rewrite it again. It is 1.64, multiply it, and we again get a C here, and here the C will be the new value we'll be getting is C is equal to 1.64 upon root n into 5 plus 390. You see, it's basically the assumed value. So it's pretty good up till now. What is left? We just need to equate these two equations, equation 1 and equation 2, and voila, we will get our answer. So 1.64 into 5 by root n is equal to plus 390 is equal to 1.64, here's minus, upon root n into 5 plus 400. So we will be getting this terms will basically, yeah, we can say this. Because of this minus here, we will just this term and this term will add on, right? And we will be getting, I'm removing this portion here. Yep. So we will be getting 2 into 1.64 by root n into 5 will be equal to 10. Simple. So 10 cancels out and we get root n is equal to 1.64, or we can say that n is basically 2 point something, right? 2.7, basically root 3 is equal to 1.732, so it would be pretty nearer to root 3, right? So we can say that n is equal to, let me just use the calculator, wait. It is 1.64 square is 2.868, so yeah, approximately 3. So that's the answer. We will be writing 3 here. The sample size would be 3. I hope you got my point here. Simple, right? So here the answer will be equal to 3. Find the critical value of C. Okay, so basically, what is the critical value? Critical value is the same thing which we found a second ago. Basically that 1.64 into 5 by root n plus 390, or you can just minus 1.64 into 5 by root n plus 400. It's up to you, whatever you want to write. So let me just calculate it again. Yeah, let me just remove this. So according to our previous results, our C was 1.64 into 5 by root n into it's plus here, yep, plus 390, right? So we can say that we just substitute n equals root n equals to 1.64, right? 1.64 into 5 plus 390. Basically, am I doing it right? Let us take the average here. So basically, yeah, we just got our answer 395 here. So I don't know why they have written correct to 2 decimal places, but yeah, you can just write 3.9500, or we can recheck it. Another value we will get minus 1.64 into 5 by 1.64 into 390, right? So sorry, plus 400 here. This also gives the same answer, which would be 395. So yeah, answer is 395. This may sound pretty confusing, but yeah, you can just write 395 here. I'll remove it later. Yep. So the answer here would be 395.00. Oh, they could have used root n as, you can also use root n as root 3. Oh, they must have used that. Root n is equal to 1.732. You can use that and you'll get just an approximate answer of something. But yeah, I'm sure that that value will be closely equal to 395. That's for sure. Okay, so you can just verify it yourself. 1.64 upon 1.732 into 5 plus 390. Okay, so it would be pretty close to 395, and that's all. 395.00 is correct answer here. So suppose, third question is, suppose x is a normal, mu and standard deviation, variance is 9. For n equals to 100 IID samples of x, the observed sample mean is 11.8. What conclusion a z test reach if the null hypothesis assumes mu equals to 10.5? Okay, against the alternative hypothesis. Yeah, so basically we are finding the probability of the alpha if I would be considering the previous case. So okay, first of all, let me just use this note. Questions are pretty big in this week, so these are quite time taking. See, it's been 22 minutes and we just solved this 2 questions, right? So here, let us suppose x is a normal, mu of 9, right? So IID samples are from x1 to x100, and we can say that x mean of normal will be mu to 9 by 100, right? So sample mean is provided as in the question 11 point. So this is all we have get. Yeah, it's also given that if we consider a null hypothesis, so h naught is equal to mu equal to 10.5, and alternative hypothesis is mu not equal to 10.5. am I right? So this is what is given in the question. So I hope you are familiar with these details. I'll just start solving question here, removing all this part. So yeah, now it's the question time. We need to find the test for, first of all, let us try for alpha, considering the options, or you can say, yeah, whatever. Let's start the test for alpha equals to, let's take the smaller value first. So a rejection level of 0.05, right? So reject hypothesis if mean minus mu is less than, greater than critical value, greater than C, right? So we can say alpha equals to probability of mean minus 10.5, which is provided in the question here, which is greater than C, given that this is the conditional. I hope you get this. Let me just use another pen for conditional. Condition to mu equals to 10.5, right? Perfect. So alpha here will be equal to probability x, basically mean here, mean of the random variable minus 10.5 upon root of 9 by root 100, because it would be root 9 upon root of n, and that root of n would be root 100, right? And that will be conditioned to be greater, sorry, that would be greater than c minus 10.5. Wait a minute, it is basically, yeah, c upon 10. I'm just getting confused here. C upon 𝗃𝗏, right? Yep. So 𝗃𝗏 says it's, yeah, 9 by 100. This is what we'll be getting, and this is modulo here, right? So now here comes the easier part. Alpha is equal to probability of z, which is the normal, being greater than c upon root 9 by 100, and from this we can for sure say that 0.05 is or we can write this part here as 2 into f of z of c upon, let me just write this thing as 3 by 10. I hope you get my point here, right? We can write 9 by 100 as 3 by 10. So this would be equal to 0.05. Old calculus, oh sorry, not calculus, old calculations. If you've done quiz 2, so you would be familiar with this part, right? So the next left is that c here will be equal to, basically let me see what is 0.25. 0.025 minus 1.96. I hope I'm right. Yeah, yeah, it is minus 1.96, minus 1.96, right? So c would be equal to 10 by 3, no, 3 by 10, 3 by 10 into minus of 3 by 10. Here we will be getting minus c, right, from the above, if we are using 2 here, so it would be minus of c into f of z of 0.025 would be, I just put the 2 here, so it would be 0.025, and I am finding the normal for that. It would be minus 1.96 as much as I remember. So this would be equal to, let me use calculator here, 0. Calculator, it is 3 divided by 10 into 1.96, 0.588. This is what we will be getting. So this would be 0.588. Okay, so we already know that 11.8 minus 0.5 will be greater than c, which is critical. So z test at the significance level of alpha will obviously reject our null hypothesis, right? So we can say that option number D is correct. I hope you get my point here. Let me just write it again, that 11.8 minus 10.5 is greater than C, which is 0.05, sorry, not 0.05, 0.588. So we can say that D option, which was the last option, is correct, right? So now here comes, if we take the alpha equals to So basically, if this option is correct, D option is correct, so C option is obviously wrong, right? So we can say D is correct and C is wrong for sure. So next is the test for 0.10. So this is basically we are checking A and B option, right? So for A and B option, we need to find this. If null hypothesis, reject null hypothesis if mean minus the given mean, expected minus given mean is greater than critical value. Okay, so here again we will be doing the same thing. So alpha will be equal to probability of mean minus 10.5 upon root. Here we will be using, rather than 9, we will be using 25 by 100. No. Question, right? 5, yeah, it would be 9 by 100. I just opened up another question on my screen, so it gave me a problem, right? So C by, let me just delete the calculator for now. Yeah, C by root 9 by 100. So here we go. Now again this function will be converted to Z. I hope you get my point here. We just did same thing we wrote in previous question, right? So here this would be the Z, and we can convert this alpha equals to 2 of fz into minus c by 3 by 10, right? So alpha here is 0.1, 0.1 by half will be 0.05, and in previous question f of z minus c by 3 by 100, 3 by 10, sorry, this was minus 1.64, right? So we can write it like this, 0.64. I'm just telling fz inverse of 0.05 is minus 1.64 will be equal to minus c by 3 by 10. This will be cancelled out, and at last we will get c equals to 10 by 3, 3 by 10 into 1.64, which would be approximately, let me just again use the calculator, 0.49. So again we can say that 11.8 minus 10.5, 11.8 minus 10.5 is greater than C, which is 0.49. We can say that B option is correct. Let me just clarify this doubt if you get one, that if the value, the difference, which is basically 1.3 here, if the C would have been greater than 1.3, then our option would be A here, right? Perfect. So here B is our answer. Perfect. So in this question, B and D. Next is, okay, a sample of 100 made from a normal distribution having the variance of 25. We wish to test the hypothesis. Null hypothesis is equal to mu equals to 0, and alternate is where mu is equal to 1.5. We need to find, basically we need to consider a test that rejects null hypothesis for expected mean greater than the critical value. So first of all, we need to find critical value at the significance level of 0.05. Okay, so it is basically same as the starting question, right? uh, the only difference is we just need to find the critical value, not the n, so the question will be easier. So yeah, here let's just use this one. So first of all, we are given that null hypothesis is mu equals to 0, alternate hypothesis is where mu equals to 1.5, basically greater than 0, right? Test is for alpha equals to 0.5 because significant level is 0.5, you can see from the question. So let's just start, and yeah, the test is also reject. Question was reject, let me just see the question again. Reject h naught for x expected value greater than c. Reject x h naught for expected greater than c, right? So here comes our question, answer. Alpha equals to probability of mean of x greater than c, reject is mu equals to 0, right? This is basically what we just wrote, the conditional probability for this test, right? So again, put the values. X mean x greater than c, so we can just convert it into normal root of. So this is what I was talking about, right? I just coincidentally saw another question. So 25 is here, c upon root 25 upon 100. Is that true? So the variance is 25, 100. See, everything is all right, perfect. So we can say that alpha is equal to probability of z being greater than 2c here. Yeah, so because when we add a c here, this will be 2c, so yeah, z would be greater than 2c, then only we will get our value. So okay, perfect. For that, 0.05 will be equal to 1 minus fz of 2c, and here we will be getting fz equals to fz of 2c equals to 0.95, and basically in a question yeah in a question from this we can say 0.095 was 1.64, yeah, 1.64 as much as I remember. 0.095, 0.095, yep, 1.64. So we can write it 2c equals to 1.64 and c would be equal to 0.82, and that will be the answer, right? .82. Now the next question is find the power of the test, answer the correct answer. Basically we need to give the answer correct to 2 decimal places. Okay, so this is basically the simple point that it is pretty easy basically from the previous question we can definitely say that we can write the power equals to 1 minus beta, and that will be equal to probability of x dash minus 1.5, right? I hope you get my point here. Divided by 25 upon 100, and that will be greater than c minus 1.5 upon root 25 upon 100. So one thing you can notice is, then rather than getting a perfect 2c here, what we will be getting is c minus 1.5. So 1 minus beta, we can just jump here, is probability. This would be z, so I'll remove that portion. 1 minus beta is 1 minus fz of 2. Rather than c, we will be writing c minus 1.5. Do you understand here? I hope this wasn't a long jump here. Let me just explain. Yeah, basically I wrote this part as z first, right? I hope you agree with me here. Now I converted this thing, basically this would be z greater, yeah, perfect. So now this would convert it to, this will convert into let me just wait a minute. This would be f of z of, because it's greater than, so we will write it 1 minus fz of 10 by 5 into c minus 1.5. Do you get that? I just simplified this term, so it would be 10 by 5 into c minus 1.5, and this is what is written here. Simple. So yeah, now let us just proceed. So this would be beta equals to fz of 2 into c minus 1.5. We already know that c is 0.82, so all left is to subtract, and 0.82 sorry for that, 0.82 0.8, wait a minute, again let me use the calculator here. 0.82 minus 0, what is this, 1.5 is equal to 0.82 minus 1.5 minus 0.168 into 2. Okay, let me just check it if it's possible or not. Yeah, so we are getting into 2, right? Into 2, so we need to find minus 1.36 here. Yeah, this portion. So basically we will be getting wait a minute, let me just check it again. Okay, so yeah, this would be 0.68, 0.82 minus 0.68, so we can write it fz of 0 fz of minus 1.36, which would 0.8, let me just check it again, 0.8691 0.8691. The decimal places are really confusing. It's 691. So yeah, This is the answer. How many places? We need to find, put two decimal places, so 0.086. You can just write between the range of 0.08 to 89, right? This I mean. So your answer would be between the range. Answer between 0.08 to 0.09. No more, no less. Okay. So great.